welcome to day 27 of our 30-day coding challenge from CS and Math. We're going to dig back into some geometry today. I want to focus on some complex area. Now, I know as a geometry teacher, we get into problems like this a lot where as we're teaching things like, let's say, regular polygons, we might put mixtures of them together, compositions or decompositions, and this is a classic one we've always used, and I've really liked it. Maybe you've done something similar, and we asked kids to find the area. And I thought, well, what if I tried to just build something like that in a program? So that is what we're going to work on today. It's one of those classic type of problems. I'm going to try to use the language around computational thinking best I can to use decomposition, abstraction, algorithmic design, and pattern recognition within the process. So get set up and let's see what we can get going. Alright, so I went ahead and put our basic turtle code in there. Remember, if we run this, puts the turtle in there. Our turtle's name is T, and we've went over a lot of stuff on turtle. If you're not aware of it, go back and watch maybe even the first challenge and see what you can see on there. A good way to do this with students might be to start with a picture like this and say, what if I asked you to find well, first of all, what if I asked you to build this, like write a program for it? How do you see it being built? What does that look like? And maybe I'll let you do that. We'll decompose it and say in that thing, like, what are some of the components, and you can just comment them out. Like, for example, I see regular polygons, right? That's obvious. And you can keep going on down the line and just see if you can't decompose this into some things. Now you could have several things, but I've tried to say this. I see a regular polygon maker, right? I see, like, if I could just have code that makes regular polygons, then I could just layer those, and I kind of see a layering the biggest one on down to the smallest one, and alternating colors, like between a color and then white, and then a color and white, and so on. Now, if you wanted to at some point show this, animations can be good prompts, but this almost gives away a lot, right? This really gives away an extra added layer. And it shows you how we're going to go about building it in this programming challenge. So let's go back to our code and jump into it. So I'm actually going to get rid of this decomposition. Now, we do a lot of lessons on polygon makers. I'm going to go fairly fast with this, but I'm going to go t dot forward, let's just say like 100. And then I'm going to do t dot right. Now let's go left, and we'll go 90. And let's just copy and paste that code 4 times. Now I'm doing something here, obviously, that... Oh, I'm sorry, I did the equals here. What am I doing? So t dot forward, not equals 100. We want to parentheses 100, and then I'm going to copy and paste that, 4 times. And you'd see that right builds a square. We've done a lot of lessons on this and kind of how to break that down. We're trying to get into some of the higher layers here with today's design. So I'm just going to forego some of that and say, well, we could just loop this. So for item in range 4, instead of copying and pasting that, let's just indent this. We'll do that 4 times. There's a nice progression you can do here. You really want to set this up well with kids. On our website, it's called Playful Polygons, if you wanted to look into that. And then you could do other shapes. Like if I wanted to do, let's say, 3 here, I could do, instead of turning 90 degrees, a lot of people think, oh, if it's an equilateral triangle, this should be 60. But actually, it's the exterior angle. So you're traveling this path, and you need to turn the exterior angle up off. So you'd actually have to do 120. Now, we do a lot with this, like I said, in some other video lessons, but today we're going to just kind of abstract this out to work for anything. We can do that. There's an exterior angular formula where you divide by the number of sides. So obviously we'd have to declare a value for number of sides. Let's say we do 3 or something like that. And then that number of sides would be how many times you loop this, and the exterior angle is going to be 360 divided by that m value. And so that actually is a form of abstraction really right there. So if we're talking about the pillars of computational thinking, this allows for a polygon maker, right? And if I change this to, let's say, 6, it now knows to loop 6 times, right? And it's going to calculate the exterior angle versus having it be something that's fixed. It's going to be something that's dynamic based on a formula. Now, we can even go a step further in the abstraction process and make that a function. So we'll call this definition of the function is going to be, we'll just call it reg poly. Actually, no, let's call it ngon, because that's kind of a lot of times what they call it in math classes. We're actually going to have this take in a parameter called n, and then that will make it so we don't have to keep hard coding in the number of sides. We could actually just put it in the call later. So we'll take in a parameter n, meaning the number of sides, and then we'll actually tab in this. And now this definition we can call down here. So right now, remember, if you run this code now, nothing happens because this is a definition. But then if you call up ngon and say, yeah, do that 6-sided shape. Well, let's do a pentagon since we haven't done that. And notice that it would make that shape. So now we have abstracted out this regular polygon maker. Now, I'm not saying this should be something that comes natural to people. Like, that's not an easy thing to just do if you're wondering, like, how in the world did all that just happen so quickly. But it is part of the puzzle, right? It is part of the process. So we now have used decomposition and abstraction in our program. All right, I'm going to just paste in a few things here for the turtle that are commands we've talked about before in previous challenges. So remember, for our turtle that we're calling t, right? Our turtle, I'm going to set a speed, let's say at 15. I'm going to make the pen just a little bit thicker. Remember, there's some of these commands where we can use. I actually don't like that it's starting at 0, 0, so I'm going to make it go left 50 and down 200. So I'm going to use a go-to command for that. I got to pick the pen up before I go there, otherwise it's going to draw a line. But now if I run this, right, it starts making it here from the bottom. So then as I build the polygons, I feel like it builds a little bit nicer in the screen if I do that. So you're welcome to copy that in quickly. And then, I think I also want to have the length of the side be variable, potentially. So if I wanted to make it go a different size, I could do that. So I'll make this length. So, and I could set this to something, let's say like 50 to make it smaller if I wanted to. And you can do the same. Let's stick with 100 maybe for now. I'll let you pause and get that set up. Maybe I'll change the size of the code here. Let you pause and see if you can get that cleaned up. Okay, so I feel pretty good. Hopefully you do too about when we decompose it, we said we would need to build regular polygons. I think we've successfully done that. We got a polygon maker. And I guess from there I want to be able to build like from small down. So I'm going to have to be able to change the number of sides that I'm putting in here. So I'm going to just make a variable, call it sides. I think in my picture, if I remember correctly, this biggest one for mine had 10 sides, so a decagon. So I'm going to start that at 10 sides, and then I'll just have this take in sides. And let's make sure that's working. Looks good. Now, obviously, I did a little bit of work to make sure it fit nicely in the screen, and you could as well. But I have my bones there of an outline, and I can now change the number of sides and kind of layer them on down. So I would do within another loop, and you could do for loops, you could do while loops, so maybe just to change it up, I'll do a while loop. So while sides is greater than 3. Reason I did that is because we can't have a two-sided shape, right? So greater than or equal to 3. So while the size is greater than or equal to 3, let's make that ngon. And then for each loop through, I would say take the sides and increment them down. So I could say sides equals sides minus 1, or I could just say minus equals 1. And what that will do is it will increment the number of sides down, and we can loop back through. Now I got to put this in the loop by tabbing it in. See if I can do that. Yeah, that should work. And there you have it. So there again is the basic structure, the outline of this thing, and we just want to color it in. So in a previous video we did that. I'm going to go ahead and pause and paste that in just so we're able to do it quickly. Actually, you know what I'm going to do? So I put in this comment here that said makes layers. I'm just doing some cleaning up. And then remember, in part of our abstraction, we wanted to put in color. So I'm going to do some pasting here, and this just says colors equals, and then I made a list of the colors that I saw. So yellow, white, red, white, green, white, blue, white, orange. So that was the list of colors that I had saw. Actually, I think there's an extra one in there. I don't think I ever got to orange. But you could make it more, right? You could make it more. So I think the last one here was blue or white. Maybe the triangle was white, but you could make a longer string of colors if you wanted to, alternating back and forth. Maybe you wanted to change the colors, you certainly could. But this now intentional list will make it so it's not random. We can actually color it however we wanted to or how we saw it in the animation. So I've got the colors in there. That way when I go and I fill this in, remember the way that we do that is it's within this loop. I could say t dot begin fill. Actually, I could probably do that before looping. Maybe right here I can do t dot begin fill. And then after it loops through, I'll just do once at the end, t dot end fill. And that is the code for filling it in with these colors. So if I run this now, right, it's going to fill them in black, and then you can't even see the other ones because they're filling in black thereafter. So we got to be able to change the color to be able to see them, right? So that's kind of weird. So in order to do that, I'm going to do this. So what I actually decided to do is I put a layer in here, a variable called layer, and that way I can retrieve like yellow then white. I don't know if a layer was the best variable name, but I use it. And then I'm saying we'll set t.color equal to color of the layer that I layer variable. So I could, if this was 0, like if layer was 0, then that would be yellow. If layer was 1, that would be white, and so on. And then what I have to do is within that, now we're calling this n-gotten function up over and over. So now I can increment layer to plus equals 1. So I notch the layers up. I could do that within the definition of reg poly, and it's fine. Or n-got, I mean. So now if I run this, it's saying that local variable, so I definitely need to make layer a global variable. So I can say global layer. So now layer is accessible out here and outside of just this function. So if I run it now, there we go. So we are alternating the colors in the layer. And again, if you wanted to change those, you certainly could. But that's it for today. I wanted to get this built, and tomorrow we're going to look into what does maybe calculating and looking at the patterns of the area. What does that look like in solving for the area? Hopefully you found this interesting and maybe learned something in the process. There's more we could do, but that's it for today. Thank you guys so much for watching. As always, you can hit that like button, hit that subscribe button. Hopefully we'll see you tomorrow.